4.3 Day 2, we're looking at right triangle trigonometry. We're going to focus on modeling and solving real-life problems. So some applications revolving right triangles is we need to remember from geometry our angle of elevation and our angle of depression. So notice that the observer is here at the bottom and they're looking up at an object. So this angle is the angle of elevation. Now, if there is an observer up at the top and they're looking down at an object, then this is what's called the angle of depression. So let's solve a right triangle. A surveyor stands 115 feet from the base of the Washington Monument, as shown here. The surveyor measures the angle of elevation to the top of the monument to be 78.3 degrees. We're going to find out how tall is a Washington Monument. So we want to look at what we're given. And so we know we have this angle here, and we have y. So what is that in relation to the angle? Well, that is opposite. And then down here, this is adjacent. So what ratio can we use? Well, we can use tangent of 78.3 degrees equals opposite, the y, over adjacent 115 feet. So to just solve, we're going to multiply both sides by 115. So therefore, y equals 115 tangent of 78.3 degrees. So then you plug it into your calculator, and you could just plug it in as a 115 and press tan, 78.3 degrees. You want to make sure, of course, that your calculator is set in degree mode. And so what you will get when you plug it in is 555.3 feet approximately. So we can say that the Washington Monument is approximately 555 feet tall. Okay, so try this example here. The angle of elevation to the top of a flagpole at a distance of 19 feet from its base is 64.6 degrees. How tall is the flagpole? So draw a picture, see if you can figure that out, and then when you come back, I'll have the answer for you. So this is a picture you could have drawn. So there's a flagpole, and the height to the top of the flagpole is 64.6 degrees. The distance from the base is 19 feet. So again, we could use tangent. So tangent of 64.6 degrees equals the height over 19. I multiplied both sides by 19, so the height equals 19 times tangent of 64.6 degrees. And when you plug it in the calculator, you would get approximately 40 feet tall. Let's look at this example here. A lighthouse is 200 yards from a bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Find the acute angle between the bike path and the walkway. Okay, so we're trying to find this angle here. So we know we're looking at this angle. We're looking at opposite over hypotenuse. So opposite over hypotenuse, that's sine of theta equals 200 over 400, and then we can reduce that. Sine of theta equals 1/2. So hopefully knowing your unit circle pretty well, or getting to know your unit circle really well, when is sine of theta 1/2? Well, hopefully you can remember that sine of 1/2, that is at 30 degrees. So that's the angle between the bike path and the walkway. You don't even have to use a calculator. Try this example here. Find the acute angle theta between the two paths shown. So we tried it out. So here is the angle. We're given adjacent over hypotenuse. So cosine of theta equals 3 over 6, or cosine of theta is 1/2. So what does cosine of theta equal 1/2? Well, that's a smaller value, and for me, I think about that it's closer to the y-axis. So that tells me that is at 60 degrees. Okay, so the angle between the two paths is 60 degrees. Let's try this example here, last example, solving a right triangle. Find the length C and the height B of the skateboard ramp shown. So we have 18.4 degrees and we have 13 feet. So let's try to write some ratios with some of the given values. So we know 18.4 and we know the side adjacent. So we can think about, let's to one where its tangent of 18.4 degrees equals the opposite over the adjacent. And so that we can solve for that. So another thing that we can use, given what we have, is we can think about, let's see, we have adjacent over hypotenuse. So adjacent over hypotenuse, that's cosine of 18.4 degrees equals 13 over c. Now really I want my c in the numerator because it makes it a little faster to solve. So one way to do that is, yes, that is secant, but instead, let's just make it a reciprocal. Let's just say it's 1 over cosine of 18.4 degrees, then flip over the right side, so that's c over 13. Okay, so now to solve, let's just start with this one that I've already started with. Let's multiply both sides by 13. So now, to solve for c, you're going to do 13 over cosine of 18.4 degrees. So make sure when you plug it in your calculator that you have enough parentheses. When you figure that out, or when you plug that in, you will notice that you will get c is 13.7 feet. Then for tangent, that's pretty fast for you to find. You just multiply 13 to both sides. So 13 times tangent of 18.4 degrees is b. And then you'll find out that b is about 4.3 feet. Okay, that should make sense. B is 4.3 feet, so that is definitely smaller than the hypotenuse, which is 13.7, and that is the longest side. So try this example down here. Find the length c and the horizontal length a of the loading ramp below. Okay, if you tried this out, one ratio you could write is sine of 11.5 degrees is 3.5 over c. Now I want c in the numerator just because it's a little faster to work with. And so I just flipped both equations as reciprocals, and then I multiplied by 3.5, so c is approximately 17.6 feet. For the second one, I wrote tan of 11.5 is 3.5 over a, and I really wanted the a in the numerator, so again I did the reciprocal of both. You'll find that a is 17.2 feet.